Okay, something a little bit different today. So I've got an online whiteboard here. We're going to try it out. I can't say that I'm going to be uh, the best at drawing with a mouse, but we'll see. So, last time we went over the basic ideas of algebra. So, for one thing, the number lines. So, we have real numbers, integers, rational numbers, irrational numbers, non real numbers, all those kind of sets of numbers. And then we also said that we have operators, and we can put numbers and operators together to make expressions. So today I want to go over these expressions and practice some of them with you. So first of all, our order of operations. First, we do our grouping symbols. Then exponents. Then multiply. And divide. Add. And subtract. Okay. So when we are dealing with expressions, we need to remember our order of operations. So again, grouping symbols first, then exponents, then multiply and divide, then add and subtract. And I should also add exponents also includes roots, as you remember. So let us try to use this order of operations to simplify an expression. Again, bear with me here. We'll see how well I do with the mouse. Not well at all. 2x plus 7y minus 3x minus 5y. So luckily for us, we don't have any grouping symbols, we don't have any exponents, we don't even have any multiply and divide. All we have here is add and subtract. Now, what we can see here is we have 2x's here, 7y's here, we have minus 3x's here, and minus 5y's here. So what we can do is we can say, well, since we have x's here and x's here, we can combine them. And again, that's what we're doing. We have add and subtract. Remember that I called add and subtract combination. So 2x and negative 3x can combine to give us an overall total for x. So 2x minus 3x is negative 1x. Or you could just call that negative x. You don't need the 1 out in front. Same way, 7y and a negative 5y, we can combine those together as well to get a total for how many y's we have. So 7y minus 5y, and that leaves us with 2y. Okay. And now we have to ask ourselves, can we do anything else? Well, remember your order of operations. Do we have any grouping symbols? No, there's no parentheses or anything like that around here. Do we have any exponents? I don't see any exponents either. Can we multiply or divide? Not really. Add and subtract? There's no more like terms to put together, so no, we can't add and subtract. So we've run out of operations that we can do, so this is as far as we can go. So this is our simplified answer. It's the exact same as what we had up here. It's just simplified. So remember that I said expressions have some value behind them. Okay? Now, these would both have the same value. So this, again, like I said, is the same as this, just in a different form. Okay, so let's try another expression. Nothing too terribly difficult. 8 square roots of 4. That is the worst looking 4 I've ever seen in my life. 4 times 4. Okay. So remember, order of operations. Grouping symbols first, then exponents, then multiply and divide, then add and subtract. So, at first glance, it might not look like there's grouping symbols in this one. However, this root does act like a grouping symbol. Whenever you see a square root, imagine that there are parentheses around whatever's underneath it. Okay? So, again, the root acts like a grouping symbol. So it's what we need to do first. So underneath this grouping symbol is 4 times 4. 4 times 4 is 16. So we will rewrite, oops. Eight square roots of, again, 4 times 4 is 16. Okay, so we've done our grouping symbols. Now we move on to exponents. Do we have any exponents? Technically, yes. Remember that I said that exponents are the same as roots. Roots are the same as exponents. In fact, we could rewrite this root as an exponent. So we're going to do this root in our exponents step. So what is the square root of 16? 4. Remember that this was 8 times the square root, 8 times the square root, so it needs to still be 8 times whatever we got from that square root. So 8 times 4, 32. This and this are the same. Again, I said that expressions have a value behind them. This one we were actually able to get to that value. This one's value is 32. All right. So, something I want to reiterate from last time, at least I think I went over this last time, is how powers work with parentheses. Okay, so if we have this here, we have parentheses, -2 in the parentheses, and then squared. And that square is sitting on the outside of these parentheses here. So what I said was a square or exponent or whatever you have for your power will act on the thing directly next to it. So in this case, the thing directly next to it is a set of parentheses. And it will take this set of parentheses and multiply it by itself. Whatever's right next to that exponent is what gets multiplied by itself. So this now becomes -2 in parentheses times -2 in parentheses. So what is -2 times -2? +4. So the takeaway here is that if we have the negative in those parentheses, we're going to include it when we square it. As opposed to if we, I wish you wouldn't do that. If we have no parentheses, Again, this exponent only acts on the thing directly next to it. And what's directly next to it? 2. So the negative is there, but it's not getting included in that square. Again, the exponent only acts on the thing directly next to it, so this is telling us to multiply 2 by itself. So 2 times 2 is 4. Apply that negative, we have negative 4. So parentheses are extremely important to keep in mind when we're dealing with these exponents. And there's another place that we need to keep them in mind. And that is when we are substituting values into our expressions. So if we have an expression, say 2x squared plus 5x minus 3, we can't do anything with this right now as it is. We go through our order of operations. Do we have grouping symbols? No. Exponents? Yeah, but, I mean, x squared, we're just going to get x squared. We can't really do anything with this exponent. Multiply and divide? No. Add and subtract? Yeah, but they're not like terms. So we can't really do anything with this as it is. It's already in simplest form. However, if we were to find a value that we wanted to plug in for x, say x equals 4, we can go ahead and put this value in everywhere we have an x. Now, here's what you need to keep in mind. If you do that, open up parentheses wherever you have a variable, wherever you have an x. And then plug this number, this value that we're using for x, into the parentheses. Okay? Oops, I forgot my square. So what this does for us is it preserves operations. And I will show you a little bit better example in a second. I just want to keep it basic for now. But by preserving operations, what I mean is that whatever we were doing up here, if we were multiplying, if we were adding, if we were subtracting, if we were doing whatever we were doing up here, it's the same down here. So for instance, 2 times x squared, we still have 2 times x, which is 4, squared. Alright, so let's go ahead and figure out what this one is. So 4 squared, that's going to give us 16. That's the only exponent I see, so I'll drop everything else down. Okay, so exponents are done. Multiply and divide. Yeah, I've got some multiply I can do. 2 times 16 and 5 times 4. So 2 times 16 is 32. 5 times 4 is 20. And then negative 3 just drops down. And now we just have add and subtract. So 32 plus 20 minus 3, it's going to give us 49. Okay. So again, what I want you to remember here is that if you plug something in for a variable, so in this case 4 in for x, we need to use parentheses to do that because it preserves our operations. And so, like I said, I want to show you another example of this. Same expression. We're just going to change one thing. now we have negative 4. So we're going to plug this in and see what we get. And remember, when we plug a value in for a variable, we need to use parentheses. Okay. So as you can imagine, if I had not used parentheses here, that kind of looks like 5 minus 4, doesn't it? If I hadn't used parentheses here, well, that negative is no longer getting included when I square. And again, this looks like subtraction instead of multiplication. So making sure that I have parentheses around here helps me know that whatever I was doing up here, I'm still doing down here. I haven't changed my operations. So again, let's figure this one out. First of all, grouping symbols. Nothing that I can really do inside the grouping symbols. There's just single numbers. Exponents, though? Yeah. I've got an exponent there. Negative 4 squared is 32. Positive 32. Then 5 times negative 4, that's negative 20. I don't need to do that step yet, but I'll go ahead and do it. Okay, 2 times 32, that's going to be, why did I put 32 there? It should be 16. 2 times 16 is 32. It's getting ahead of myself. Okay, so now we have 32 plus negative 20 minus 3. So 32 minus 20, then minus 3, that's going to give us 9. And there we go. So again, using parentheses when we plug things in for our variables helps us make sure that we are preserving our operations, making sure that all of our operations are the same as what they were before. Okay. Next, I have some new operators to show you. First, this. So if you see vertical lines like this around a number, what this means is absolute value. So think about it like this. If I have a number line, zeros in the middle here, 2, negative 2, is 2 steps away from 0. So 1, 2 steps away from 0. 2 is positive 2 is also 2 steps from 0. So negative 2, positive 2, it doesn't matter which one we're talking about. They're both the same distance away from 0. And so what absolute value is asking us is, all right, treat this as the distance from 0, not the actual positive or negative number. So we would say that the absolute value, or the distance that this is from 0, is just 2. Because it is 2 steps from 0. Another way you can think about it is if there's a sign on it, you just cancel the sign out. It's not really what you're doing. You're treating it as a distance. But in the Short term, yeah, you can just think about it as we're getting rid of the sign on that number. Also, these absolute value signs act like grouping symbols. So if I have absolute value of 5 minus 3, what I would say is, well, these are grouping symbols. I need to do what's inside of them first. So 5 minus 3 gives me 2. And then I say, all right, so what is the absolute value of 2? Well, again, its distance from 0 is 2. So there we go. So once again, absolute value treats it as being a distance, and you can't have a negative distance. I mean, negative 12 feet doesn't make a whole lot of sense. Okay. And the last operator I want to show you, or two of them really, is union and intersection. Now, these don't work on just plain old numbers. What they do is they work on sets. Remember, sets are things like our set of rational numbers or our set of natural numbers. They're groups of numbers that have some kind of rule that says what can be in that group. So, like our natural numbers, the rule there is it's our counting numbers. It's 1, 2, 3, 4, 5, 6, 7, 8. Things you use to count with. We don't have negatives and 0 in there. So the set, the group of numbers is 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth. I can make up a rule that says that my set only has the numbers 1 through 5 in it, or the numbers 1 through 20. Okay, and here's how I would show that group. I have a start point, 1, and I have an end point, 20. Now these brackets on each side say that I'm actually including these numbers. 1 is part of the group, 20 is also part of the group. You can have parentheses around them, and that says we're starting at 1, but we're not actually including 1. So really it would be starting at like 0.000000000000000 somewhere, or really I guess it would be 0.99999999999. It'd be starting somewhere around there, but we're not actually including that 1. But since we have the bracket around it, we are including it. So what I can do with this set is I can perform either a union or an intersection with another set. So let's say I have another set. I'll say it's 6 through 10. No, that's not a good one. 6 through 40. Okay? So what I can do, again, is I can either perform a union or an intersection, depending on what I need to do. So a union, let's see, where is my sticky notes? A union joins sets together. It's like glue. It takes two sets and makes them one set. So instead of having 1 through 20 and 6 through 40, I'll have all the numbers from 1 to 40. So again, if I do a union, which the union symbol looks like a big U, it joins them together, gives me a new set with all the numbers from 1 to 40. And there's my new set. Okay? So, like I said, it acts like glue. It takes two separate sets, puts them together so that they're only one. Now, there is another one called intersection. And intersection, instead of being glue, it's like scissors. It cuts out only what it wants. So what it cuts out is what they have in common. Anywhere that these two overlap, it's going to cut that out and give that as its set. So its symbol is like an upside down union. Upside down U. And again, it just clips the numbers that are in common. So what do these have in common? Let's see. Well, it keeps going until it gets to 6. 6 is the first number that they have in common. So that's our start point. And then it goes to 20. After that, they don't have anything else in common. So there's our new set. Okay, so like I said before, union is like glue. It puts the two sets together, makes them one. Intersection is like scissors. It cuts out the things that it wants and just has what's in common. Okay? So, I think that is everything we covered in class today. A little bit short, only about 30 minutes. So next time, I'm planning on having just some in-class work day. It's for everybody to make sure they're caught up on Hawks and have all their assignments done and they're ready to go for the next section. And so I will send out instructions for Wednesday. I'm not sure that we're going to have an actual lecture Wednesday for us in the Zoom class. And I'm probably just going to let us work and catch up just like I'm doing for my regular lecture class on Wednesday. Other than that, though, I hope everybody has a good day, and I will probably see you Wednesday, but most likely on Friday as well. So I hope you have a good one.